Hello everyone, thanks for listening. My name is Yaru Hao. I will give the presentation of investigating learning dynamics of BERT fine-tuning. While the recently introduced pre-trained language model BERT advanced the state-of-art on many NLP tasks, there are two approaches to adapt the pre-trained language representations to the downstream tasks. One is the feature-based approach, where the parameters of the original pre-trained BERT model are frozen when applied on the downstream tasks. Another one is the fine-tuning approach, where the pre-trained model and the task-specific model are trained together. We know that the fine-tuning approach of BERT generally outperforms the feature-based approach, but it's unclear how fine-tuning helps BERT to improve performance on downstream tasks. So in our work, we investigate on the learning dynamics of BERT fine-tuning. The model architecture of BERT is essentially based on the multi-layer bidirectional transformer, the core function of which is a self-attention mechanism. We first use Jason channel divergence to measure the change of the attention mode during fine-tuning. While the attention score implies the inherent dependencies between different words, the output representation of every layer is the practical feature that the model extracts. We use SVCCA to quantify the change of these out representations during fine-tuning. We employ the BERT large model on 4 NLP tasks. The hyperparameter choice is the same as the original BERT paper. The indicator of the attention mode change is given by the left formula. We compute J's divergence of attention scores between the original BERT model M0 and the fine-tuned model MT on the development set by calculating the average of the sum of the G's divergence at each word and each attention head for every layer. From Figure 1, we observe the attention mode in lower layers and intermediate layers do not change seriously, while the attention mode of less layers changes drastically. It indicates that the fine-tuning procedure has the ability to keep the attention mode of low layers consistent with the original BERT model, and changes the attention mode of the less layers to adapt BERT on specific tasks. As for the feature extraction mode, we use SVCCA as a metric, where C denotes the hidden size of BERT. Rho is a CCA resulting in a value between 0 and 1, which indicates how well correlated the two representations derived by two models are. Figure 2 is the SVCCA distance of individual layers between the original BERT and the fine-tuned model. Figure 3 is the SVCCA distance of the last layer between two models with the parameters of a target layer replaced with its pre-trained values. We observe the change in the intermediate and last layers will increase the SVCCA distance, which reflects that fine-tuning mainly changes the feature extraction mode of intermediate and last layers. Moreover, we investigate the consistency of different fine-tuning procedures, including the consistency between different random seeds and the consistency between different datasets. First, we fine-tune two models on every dataset with the same hyperparameters but different random seeds. As shown in Figure 4 for a large dataset MNRI and SST. The attention mode of low and intermediate layers is basically consistent between two different random seeds, whereas the attention mode of less layers is relatively divergent. Figure 5 illustrates the SVCCA distance between different random seeds. We observe that the SVCCA distance gradually increase in all layers, the increase of less layers are more obvious. Second, we investigate the consistency between different datasets. We fine-tune two models on two different datasets, then evaluate on a combined dataset containing 20 examples respectively from those two datasets. Figure 6 and Figure 7 demonstrate that no matter two datasets are from the same domain or the different domain, the attention mode and the feature extraction mode of low layers are consistent, which indicates BERT studies some common language knowledge during the pre-training procedure, and low layers are stable to change their original modes. In addition, the consistency between datasets from similar tasks, like RTE and MRI, is still relatively strong in less layers compared to the consistency between datasets from the different domain. In conclusion, if we investigate on the learning dynamics of BERT fine-tuning, we use JS divergence to detect the change of the attention mode, and use SVCCA distance to detect the change of the feature extraction mode. We observe that BERT fine-tuning mainly changes the attention mode of less layers and modifies the feature extraction mode of intermediate and less layers. We also demonstrate that the changes of low layers are consistent between different random seeds and different datasets, which indicates that BERT learns common transferable language knowledge in low layers. In the future, we would like to explore learning dynamics for cross-lingual pre-trained language models. Thanks for listening.